Hello everyone, this is Divya here, and today I will be discussing about a synthetic reagent called N-bromosuccinimide. And this N-bromosuccinimide is commonly abbreviated as NBS. NBS. This is the common name of N-bromosuccinimide, and this is the structure of N-bromosuccinimide, where N is having bromine over here, and this is a succinic acid derivative where it will be having 4 carbon atoms. So this is the structure of NBS, and this is mostly used for the allylic and benzylic bromination. NBS is mostly used for the allylic and benzylic bromination. Now we will see how this is prepared. So this is prepared by treating succinimide with base and bromine. So succinimide is nothing but this one. This is the structure of succinimide, and if you are treating with OH minus, this hydrogen will be deprotonated like this, minus H2O, and you will be getting a negative charge over nitrogen. This is thing. Now this will be reacting with bromine. This will be attacking bromine, and this Br minus will be clean. So minus Br minus, and you will be getting the desired N-bromosuccinimide. NBS. This is how NBS is prepared. NBS is prepared. Now, as I said earlier, it is used for the allylic and benzylic bromination. For example, let us see a few examples of allylic and benzylic bromination. If I am taking cyclohexene, so this is the double bond over here. Here we have two positions. One is allylic positions. This is a vinylic bond, and you have two allylic positions, like one is over here and the other one is over here, allylic positions. So bromination will be happening at any one of the positions. So if you are treating this with our NBS, N-bromosuccinimide, the product, and this reaction is a radical reaction, and you must need a peroxide initiator for this reaction, and the product that you will be getting is one of the allylic positions will be brominated. So bromine is coming over here, and you will be left behind with N-bromosuccinimide. So this is the thing that you will be getting after the reaction. So bromination of allylic compounds is useful for the synthesis of conjugated diene. How this will be happening? Suppose you brominated this allylic position, and if you are treating it with a base, what will happen? As you know, here there is a hydrogen, then there will be a beta elimination like this. So minus HBr will be eliminated, and the product that you would be getting is like this. So you are ending up with a conjugated diene. This is the application of NBS. So after you brominate at the allylic position and followed by a base treatment, you can prepare a conjugated diene. So as I said earlier, this allylic and benzylic compounds are more reactive than saturated compounds, and as I said earlier, this bromination is a radical catalyzed halogenation, and it is having selection of reaction. Okay, so allylic compounds, if you have allylic compounds for example, this is an allylic compound, and if you are doing halogenation, this is our allylic position here. This is our allylic position. A hydrogen H dot will be going with HX. Okay. So what you will be getting? This R, here you will be generating a radical R dash, and this radical can rearrange also like this, homolysis, right? So you may be getting a radical over here also, this side, depending upon the stability. Okay, these two are possible. So after the reaction with halogen, what will happen? You can have a mixture of products, one with halogenation over here. So the halogen will be coming over here, R dash. The other product will be like R, X, double bond, R dash. So in effect, you will be getting a mixture of products after rearrangement. Now let us look into the mechanism of N-bromosuccinic acid catalyzed bromination. So for that, there should be an initiator, radical initiator. The reaction will be taking place in stepwise. So first step of which is we will be having our N-bromosuccinimide and AIBN initiator, isobutylonitrite, and this will be picking up this bromine, and you would be getting N dot free radical plus Br dot. So radical, this initiator will be generating radicals. Okay. Now in the second step, we will be having our allylic compound. For example, if I am taking CH2 single bond, double bond CH2 plus Br dot. Now what will happen? This is the allylic position, right? So here homolysis will be happening. This H dot will be going with Br as HBr, and you will be generating an allylic radical. So you will be getting HBr plus CH2 dot single bond CH double bond CH2. So this is called allylic radical. Now in the third step, what will happen? The N-bromosuccinimide, another molecule of N-bromosuccinimide will be coming into picture, and it will be reacting with HBr and the product will be N-bromosuccinimide plus bromine molecule. Now in this step 4, this our allylic radical reacts with this bromine molecule. Again, this radical will be triggering the homolysis of this one. Okay, so you will be getting the bromine attached to the allylic position, CH double bond CH2 plus Br dot, like this. So as we got in the first step. So similarly the reaction will be going on like this. So this is the mechanism of NBS bromination. Let us see some examples of allylic and benzylic bromination using NBS. Suppose we are taking toluene. So this is toluene, as you all know, and if you are treating with NBS, what will happen? It will identify the allylic position. So this is the benzylic position. Okay, so bromination will be happening over here. So the product that you will be getting is CH2Br over here. So benzyl bromide will be the product. Now let us see another example. This NBS is not only good for brominating at the allylic and benzylic position, but also it is used for the bromination of propargylic position. So here if you are seeing, this is a triple bond and this is the propargylic position. Propargylic position. So this bromination could also happen at the propargylic position. So the product that you will be getting is, as I said earlier, this is the propargylic position and you will be getting bromination over here. Now another important example is that is very interesting. You have cyclohexanone over here and NBS. Okay, so here the expected product will be alpha brominated one. Here you will be getting bromine. So that means this NBS is also effective in the bromination at the alpha position of ketones. Bromination happens at alpha position to ketones. So that is a third very good example. Now if you are comparing the positions, like if you have a compound in which you are having double bond and triple bond, that means propargylic position as well as allylic position. So that means this position is prone to bromination as well as this position. So which will be doing? So you have to keep in mind that when triple bond and double bond are present, the preference will be for triple bond. So that means this position will be brominated. So the product that you will be getting is the propargylic brominated one. So this will be the product. Okay. Now some other interesting examples, like if you have naphthalene system. Okay. Now here if you have a methyl group and if you are treating with NBS, the product would be here CH2Pr. Okay, this is the benzylic bromination. So similarly, if you have heterocyclic ring system in the similar manner, suppose you have a methyl group over here and doing NBS bromination, same allylic bromination or benzylic bromination will be happening, and here you will be getting brominated. Okay, now another an important example is this one. A typical example where there is a competition between the allylic positions. Okay, so here keto group, okay, here double bond. Now if you are treating with NBS, what will be happening? Now if you are looking at this one, as we discussed earlier, there is a possibility of bromination at alpha to keto position. That means this is a keto group. Here alpha to keto position bromination possibility is there. Second possibility is that this is a double bond and this is the allylic position. That means allylic bromination. Okay. Now if you are seeing over here, here also there is one hydrogen, so this position also possible. So if you are seeing, this is secondary allylic, right? And this is tertiary allylic, and here this is alpha to keto group. So both allylic bromination as well as alpha position at keto group is coming into picture, and actually there is three plausible site for combination competition. So in that case, preference will be going to, if you are having ketone as well as allylic position, the allylic bromination will be dominating. Okay, so this you can roll out, and this will be happening, allylic bromination. Now in allylic bromination also you have secondary position and tertiary position. Okay, where it will happen. So if you are having two sites, like one is secondary methylene group, and the other one is tertiary methyne group, right? Methyne group. Then that case the secondary allylic will be getting preference. The secondary allylic. So that means this site will be getting preference. So the product that we will be expecting is here double bond, here bromination will be happening. So this will be the product that is getting after NBS bromination. So the applications of NBS bromination is that it is used for allylic and benzylic bromination plus bromination at alpha position of keto group. So these are the main application of NBS bromination. So as I said earlier, NBS is widely used as a brominating agent. Okay. Now it is also used as an oxidizing agent in some cases. Oxidizing agent. Okay. So it oxidizes secondary alcohols into ketones. So that is the purpose of NBS. Okay. So for example, if you have a secondary alcohol of this sort, okay, and if you are performing NBS oxidation and the product that will be getting is this type of ketone plus HBr plus N-bromosuccinimide NH. Okay. Now, if you are having primary alcohols, okay, primary alcohols, if you are doing NBS oxidation, you will be getting aldehydes. So this is the another use of NBS oxidation. So this is ethanol I am taking, and if I am doing NBS oxidation, ethanol will be oxidized to acetaldehyde. In certain cases, NBS acts as highly selective oxidizing agent. For example, if you have a cholesterol molecule, this type of cholesterol molecule it's a polycyclic compound actually. Suppose this ring will be expanding, and here you will be having a methyl group, and here OH group, and here a secondary alcohol OH group, and here also OH group. Okay. Now if you are performing NBS oxidation, this NBS will be selective to this secondary alcohol, not to this one and not to this tertiary alcohol. Okay. So the product that you will be getting is remaining things will be as such, and here you will be getting keto group, here the OH group, here methyl group, this is another ring, and here OH. So that's all for the applications of NBS. So in this one we have discussed the preparation of NBS, the application of NBS as a brominating agent like allylic bromination and benzylic bromination, and also the use of NBS as an oxidizing agent for the oxidation of alcohols and ketones. Thank you for listening.